I want to show here a diagram of how to represent the water flow, the water cycle in a space-time axis diagram. So in this diagram we can see here we have an x-axis and we have a t-axis. And so the water evaporates here at the ocean, and then this solid line shows that it's flowing through the air inland, it gets blown inland. And here it condenses into rain, and then it flows back out in a river. And so it's at a later time when it gets back out to the river. So that's a simple representation of the water cycle, the large water cycle, as it goes from the ocean to inland to rain and then back out as a river. So here we can see two events. So we could see down here that the water is flowing in through the air. It forms a cloud, rains to the ground, and then flows back out to the river. And then there's a bit of a pause before the next wind blows in. Maybe it's a couple days here, and then a wind comes in, and then the water flows back out. So in this case, we can see there's actually a gap here where there's actually no water on the land, and it's just two separate events. Now we're going to see what happens if we actually have the water not just going through the river, but also through the soil. So here, again, we have the time and the space, and we have it here, the ocean. The water comes in from the ocean, blows inland, comes to a certain point where it rains, and then it goes through the soil. And you can see here that the gradient is a little bit different than for the river, because it actually flows slower through the soil. So you can see it's actually taking more time as it flows back out towards the ocean, but it's a little bit slower. And then when it gets to a river, it actually starts flowing a bit quicker. And you can see here there's less time it takes to flow back out. So basically, the shallower this slope is, the faster it's flowing out, the velocity of the water. So now we can take a look here at the same kind of, we have the same two events here of water blowing in from the ocean as here, but the way it goes out is different. And we can see here, if the water blows in from the ocean, forms rain, and then it goes through the soil, goes back out to the river, and then the second event comes in, flows through the soil, and then goes back out as a river. But here we can actually see, even at this point in time, you can see over here that there's actually no water on the land. Over here, we can see that the water is still on the land. It's here on the soil. And so this diagram is quite useful because it allows us to see that at all points in time, there's actually still fresh water over the land. And that's because the water velocity as it slows out is taking time. It's actually taking the time through these soil paths, where it wasn't here in this diagram, where it's just gone straight to the river and flows all the way back out. So you can see if we actually have the time spent in the soil, that over time we're actually going to get more and more fresh water over the land. So here's another example. Here I'm going to do the small water cycle. So in a small water cycle, the water will flow in from the ocean to the land, and then it'll form rain. And then it can go through the soil for a little bit, but then what happens is it evapotranspires, and so it goes back in the air. Maybe there's wind blowing inland further, so it blows for a little way where it forms rain again, and it flows again through the soil, and then it might get blown out towards the ocean this time for a little bit before it forms rain again, it flows through the soil, and then it gets blown inland this time. So this is an example of a small water cycle where it's getting blown all over the place, but it's still staying over the land. So we can see here an example of a small water cycle, and so the water comes into the land. It just gets blown around, so it's cycling around like this. And then we can have a second event, and the water comes in, and it's just cycling around. It gets blown inland, goes through the soil, goes through a river for a while, then gets blown inland again, and then flows through the soil. So it's just so that you can see at any point there's actually quite a bit more water. And you can compare that to this diagram, so some of the earlier diagrams. So you can see here, this is the same two events of the water coming ocean, but there's periods where here there's no fresh water and later there's no fresh water. And then here, when it flows through the soil, you can see there's points when there's actually two amounts of water here, but most of the time it's just one. If you draw a line across horizontally, and however times it intersects is the amount of water. So this would be just one amount of water. Here'll be two amounts, and here'll be one amount. Whereas here, if you take a look, once it gets to about this point in time, If you draw a line anywhere, there's always two amounts of water. So the small water cycles increase the amount of fresh water on the land.